Hello students, welcome to Trunkie Academy. I am Dr. Pallavi Kulkarni and today we are going to discuss one new topic from chemistry from class 11. Let me just write down the title of the topic. So today we are going to discuss the topic which belongs to the chapter from organic chemistry part, and that is nothing but hydrocarbons. Let me just write down the title and then we'll start. Yes, so the topic for today's discussion belongs to the chapter hydrocarbons. And in that we are going to discuss today the homologous series. In this we are going to discuss today homologous series. Okay, first of all let me just briefly explain what is the meaning of the word hydrocarbon to you in just 2 to 3 minutes. Okay, so you know that there are n number of compounds present in nature, out of which some of them are made up of carbon, hydrogen, some of them are made up of some other elements as well, right? So those compounds which are made up of carbon and hydrogen, okay, those which are made up of carbon and hydrogen are called as hydrocarbons. Okay, can you see the word itself indicates hydro stands for hydrogen and carbon. The compounds which contain hydrogen and carbon in them are called as the hydrocarbon. So these hydrocarbons are of different type. Basically there are two main types of hydrocarbon. So first type is called as aliphatic hydrocarbons. Aliphatic hydrocarbons, which are also called as open chain hydrocarbons, aliphatic hydrocarbons. And another type is the aromatic hydrocarbons. Aroma stands for smell. Those hydrocarbons, those organic compounds which had smell, they were previously called as aromatic hydrocarbon, but later on it was discovered that there are certain compounds which are not having any smell, any aroma, but still they are having the properties of aromatic hydrocarbon. We are not going to discuss about aromatic today. We are going to focus on aliphatic hydrocarbons. In aliphatic hydrocarbons again there are two types. So first type is called as the open chain hydrocarbons, open chain aliphatic hydrocarbon, and second type is the cyclic hydrocarbons. Cyclic hydrocarbons are also called as alicyclic hydrocarbon. Ali comes from aliphatic, cyclic they are cyclic, that is they contain the cycle in them, right? Now in alicyclic we are not going to discuss alicyclic today. We are going to discuss open chain hydrocarbons today. In open chain hydrocarbons again there are two types. First type is the saturated hydrocarbon, saturated open chain aliphatic hydrocarbons. I am not going to write down in detail, only I will write down saturated hydrocarbon. And another type is unsaturated hydrocarbons, unsaturated aliphatic open chain hydrocarbon. Unsaturated aliphatic open chain hydrocarbons are again of two types. First one is alkenes, which contain carbon to carbon double bond, whereas the next one, second one, is alkynes. Alkynes contain carbon to carbon triple bond. Okay, whereas the saturated open chain hydrocarbons are nothing but alkanes, which strictly contain carbon to carbon single bond. So in today's discussion, in today's class, we are going to discuss about the saturated and unsaturated hydrocarbons, how to write down or how to draw their homologous series. That part we are going to discuss in today's session. Okay, this chart, you can just take a screenshot of this chart first of all. If you have any doubts in between, you can anytime ask me in the chat box. I am sending a message in the chat box here, you can see. If you have any doubts, you can ask the doubts in the chat box. I hope you have taken a screenshot. Now let us see what is the meaning of homologous series. Okay, so homologous series means what, and how to write down that homologous series, that we are going to discuss. Okay, so homologous series, this is a series of compounds. This is a series of compounds with same general molecular formula. As the general molecular formula is same, their properties are also same. The property I am not write down here. Same general molecular formula, and adjacent members of the series differ from each other by CH2 group. Okay, CH2 group is also called as methylene group. Okay, CH2 group is also called as methylene group. Okay, adjacent members differ from each other by the methylene group, CH2 group. Okay, so this is called as homologous series. Now today I am going to explain to you one such a simple trick to write down the homologous series of alkane, alkene and alkyne at in one table only, right? If you remember this table, you will be able to understand how to write down homologous series, how to write down the formula for 28 organic compounds in just one table. You need to remember only few things for that. Okay, yes, what are those few things? First of all, you need to remember the root words. Okay, about root words in IUPAC nomenclature I have already told you. Okay, you know there are different root words for number of carbon atoms present in that particular compound, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Okay, so root words are this table I have already given to you. I am just giving you again. So meth, eth, prop, but, pent, hex, then hept, then 8 is oct, 9 is non, and 10 is dec. Okay, these 10 root words, only these 10 words you have to remember here. Okay, yes, so this is the one part. Apart from that, you have to remember the general molecular formula of hydrocarbons. Okay, to remember that also I am going to tell you one trick. Okay, so first of all, let me just talk about the alkanes. So for alkanes, the general molecular formula for alkanes alkane general molecular formula of hydrocarbons also you have to remember. Hydrocarbons and their general MF stands for molecular formula. Okay, yes, so first of all, if it is an alkane, alkanes have CnH2n plus 2. Okay, here N is nothing but the number of carbon atoms. Then next is alkenes. Alkenes are CnH2n, and the third one is alkynes. Alkynes are CnH2n minus 2. Okay, yes, so these are the general molecular formula, and as I have told you here, N is equal to number of carbon atoms. Okay, number of carbon atoms in that particular hydrocarbon. Okay, yes, to understand this, let me just give some examples to you. Let us see first of all, if N is equal to 2, if N is equal to 2, okay, if N is equal to 2, then alkane will be, yes, what will be alkane formula? CnH2n plus 2, that is Cn is 2, H is 2n plus 2, 2 into 2 plus 2, that is equal to C2H6. Okay, and C2H6 is nothing but ethane, right? C2H6 is nothing but ethane. Okay, yes. The next I will write down about alkene. For alkene, what is the general molecular formula for alkene? CnH2n. CnH2n. Okay, so it will be C2H2n, that is 2 into 2 4. Okay, and which is called as ethene. Okay, then last one is alkyne. For alkyne, it is CnH2n minus 2. Okay, it will be equal to C2H 2 into 2 minus 2, that is equal to C2 2 into 2 4, 4 minus 2 2, so it is also 2. Name of this compound is ethyne, right? So these are the formulas for alkynes, right? Now there is one very simple concept related to that. What is that? You know, if I write down the structure of alkanes, all the alkanes have only single bonds, right? 2 carbon atoms are there, and each and every carbon atom should be attached to how many bonds? 4. Carbon should be tetravalent in nature. These things we have already discussed previously. So this is nothing but an alkane. You can see CnH2n plus 2, that is C2H6. C2H6 is nothing but ethane. Okay, yes. Now what happens if we are removing 2 hydrogen from this alkane? Okay, if we remove minus 2H, 2 hydrogen atoms from this. Okay, for example, let us say these 2 hydrogen atoms. Okay, so what will happen? C, and then every C will be attached to only 2 hydrogen atoms, right? Okay, now you can see every carbon is attached to only 1, 2 and 3 bonds. That means the tetravalency is not satisfied. That means there should be a double bond here, right? Yes, so this is nothing but CnH2n alkene, C2H4, that is nothing but your ethene. Right? Okay, again if I further remove 2 more hydrogens from this, again minus 2H, so let us say this one and this one. Okay, so every carbon will be attached to only 1 hydrogen in that case, like this. Now you can see to satisfy valency there will be a triple bond, so it is CnH2n minus 2, that is C2H2, that is nothing but ether. So you can see in the formula of alkane to alkene there is a difference of 2 hydrogen. Alkene to alkyne there is a difference of 2 hydrogen, right? Okay, so these are some basic things needed to understand this homologous series. You can just take a screenshot of this page first of all, and then we will actually start writing the homologous series. Take a screenshot. I hope you have taken a screenshot. Now let us see how actually draw the homologous series. As I have told you, in just one table I will tell you how to draw the homologous series for all the 28 molecules. Okay, how many? 28 molecules. Listen carefully. So first of all, yes, first of all alkanes, their molecular formula. And their molecular formula. For alkanes, as we know, it is CnH2n plus 2. Right? Let me just write down first of all names. For alkanes, the name ends with ANE. Okay? The name ends with ANE. Right? Yes. So let me write down the names of alkane. So meth is the root word. Just next to the root word you have to write down ANE. Right? Meth is the root word. Next to the root word you have to write down ANE. Eth, ANE. So ethane. Next prop, ANE, propane. Next but, ANE, butane. Next pent, ANE, pentane. Next is the hex, ANE, hexane. Then is the heptane. Then is the octane. Then is the nonane. And then is the decane. Okay, so these are the names, very easy to remember. Just next to the root word which I have told you, you have to write down ANE. Right? Yes, for first C is n is equal to 1, it will be CH4. Then for it is C2H6. Now every time, instead of putting the value of n in the formula and writing down, you can simply do one thing. As I have told you here, every homologous series differ adjacent members of the homologous series differ by what? CH2 group. Right? So the same thing you can use here to write down the formulas for the homologous series. Simply go on adding the CH2. Right? So that is also very easy. So I will go on adding C first of all. 1 C I will add C4, C5, C6, C7, C8, then C9 and C10. Okay. Okay, C I have added. Simply go on 2 hydrogens on each step. So H6 will be H8, then H10, then H12, then it will be H14, then it will be H16, H19, then it will be it's H18, then it is H20, and then it is H22. Right? Very easy. Okay, similarly alkenes. Now you can see the difference in the names of alkane and alkene. What is that difference? There is a difference of E. Right? What is the difference? There is a difference of E. Okay, just there is a difference of one letter. Same thing we are going to follow for the name of alkene also. Simply A from alkane we are going to replace by E. That's it. Simply A from alkane you are going to replace by E. Now what I have told you at start, do you remember? Alkanes contain carbon to carbon single and carbon to hydrogen single bonds. Right? Okay, alkenes contain carbon to carbon. Alkenes contain carbon to carbon double bond, at least one, and carbon to hydrogen single bond. Apart from that, in alkenes, carbon to carbon single bond can also be present. I will write it down here above. What type of bonds can be present in alkenes? Carbon to carbon double, carbon to carbon single can also be present, right? And carbon to hydrogen single, right? Okay. This thing also I will write down here above. Yes, for alkane, what I have told you, only carbon to carbon single and carbon to hydrogen single, right? Yes, and in case of alkynes, let us see. In case of alkynes, we have carbon to carbon triple, at least one triple bond, carbon to carbon single, and carbon to hydrogen single bonds, right? So these are the types of the bonds which are present in these alkane, alkenes and alkyne. So as far as alkanes are concerned, if there is carbon to hydrogen bond, then in that case also that is called as an alkane. Therefore, we were able to write down the formula of an alkane containing only one carbon atom. But in case of alkenes, what I have told you, at least one carbon to carbon double bond, that is the necessary condition, right? If there is only one carbon, we are not able to write down the double bond in it, right? Therefore, for here one carbon, I'll put dash. Not only for alkane but for alkynes also I'll put a dash. Why? Because if there is only one carbon atom, we cannot have carbon to carbon double bond, right? Therefore, in nature there is no any alkene, no any alkyne containing one carbon atom, right? Do you understand? Okay, yes, but we can write down from carbon number 2. Okay, just what you are going to do, the A of alkane you are going to replace by E. That's it. Okay, so what will be the name of this alkene? Ethene, right? Then this will be propene. Just A you are going to replace by alkene. Then this will be butene, then pentene, then hexene, then heptene. Just A you are going to replace by E. Then octene, then nonene, then decene. Okay, yes, so very fast we could write down the names of all alkenes. Then names of alkenes, formulas of alkene also we can write down. Formula is CnH2n, right? So simply it will be C2H4, right? Simply it will be C3H6. Can you see the difference in the adjacent formula of alkane and the alkene is of only two hydrogens, right? So you can write down the formulas by observing the corresponding alkane formula also, right? Or you can use the same trick, go on adding CH2 at each step, right? C7, C8, C9 and C10, right? Hydrogens, two hydrogens you are going to add at each step. 8, 10, 12, 14, 16, 18 and 20. That's it. Very easy, we could write down all the formulas in just 1 second. Okay, then for alkynes we will write down. Now for alkynes, what I have told you, for alkynes the difference is Y, right? A is replaced by Y and the molecular formula is also decreased by 2 numbers, CnH2n minus 2, right? Names also, A you should replace by Y, so this will be ethyne, propyne, then butane. Just simply you are going to replace A of alkane by Y, right? Then it is pentyne, then it is hexyne, then it is heptyne, then it is octyne, then it is nonine, and then it is decyne, right? So in just less than 1 minute you could write down the names of all alkynes and alkenes, right? Same for the formula. The general molecular formula is CnH2n. So if n is equal to 2, H will be equal to 2n minus 2, that is equal to 2. right? So again here also you can use the same trick. Go on adding the CH2 at each step. C3, C5, C6, C7, C8, C9, C10, right? And for each hydrogen we are going to add 2 hydrogens at each step. So 4, then 6, then 8, then 10, then 12, then 14, then 16, and then 18. Okay, yes. So this is how in just less than 1 minute we were able to draw the molecular formula, names, and all the things related to the alkynes and alkenes and alkynes, right? Okay, so this table is really very important. If you understand this table, you will be able to solve all the questions related to the homologous series, right? Okay, now I'll just highlight. Okay, so these 10 members are nothing but, you can add more than 10 members also, it's not up to 10, it's more than 10 also, right? But for class 11 only up to 10 members is fine. For next year you should know the next 10 molecules or next 10 members. Okay, so these 10 members can be called as homologous series of alkenes. Okay, homologous series of alkenes, they will have similar physical and chemical properties. Their general molecular formula is same, CnH2n plus 2. And the next one, this portion, all these 10 members, they can be called as homologous series of alkenes. Okay, then they are having the similar properties, physical, chemical, and they have the same general molecular formula, CnH2n, and all of them have at least one carbon to carbon double bond, right? Yes, then this last 10 members, they can be called as homologous series of alkynes. They have similar chemical and physical properties, they have same general molecular formula. Yes, so now you can take a screenshot of this page. This, by this 28, by this chart, if you remember this chart, you will be able to remember the 28 names of the 28 molecules, their formula, and the homologous series also. Take a screenshot fast. Okay, now you are going to observe few things here. Okay, so just let us see the alkanes, alkenes, and alkynes of the with the same carbon number, right? Any row you can take. For example, if I take the 4, okay, so this is the, I will just highlight this row, and so that you will understand. Any row you can just take for an example. Just give me a second, I will just highlight it so that you will be able to understand. Okay, now in this I have taken the example for 4 carbon atom. So in this I'm going to ask you some question, or I'm going to ask you to observe few things in this homologous series. So if you can see, so first of all I will write down the butane whose molecular formula is C4H10. Okay, if I remove two hydrogens from it, right, then I will get C4H8. If I remove two more hydrogens from it, I will get C4H6. Now this is nothing but butane, this is nothing but butene, this is nothing but butane, or in another language we can say this is an alkane. Okay, this is an alkene, this is an alkyne, right? Okay, now this not only for butane but for any number of carbon atom, any carbon number you select, you will observe the same thing. The formulas, they are decreased by just two hydrogen atoms, right? Those two hydrogens obviously they are for the double and triple bond formation, right? Okay, so in this case, in case of butane, for an example, if I am talking about butane, so let us see its structure. Butane, in which 4 carbon atoms are there, C4H10. If I draw 4 carbon atoms like this, okay, then to satisfy the tetravalency, I will just go on attaching the hydrogen atoms, required number of hydrogen atoms wherever required, right? So this is the structure, this is the complete structure for the butane molecule, right? Okay, now let us talk about the next example, that is butene. Okay, now here is the next question or next thing I want to explain to you. C4H8 is the formula. What I have told you guys, there should be at least one carbon to carbon double bond. Double bond can be here, it can be here also, right? Double bond can be here, it can be here also. On the basis of the position of double bond, we are going to have different names, different IUPAC names for these butene, right? Therefore here I will draw all the two possibilities, that is double bond can be present at in between first two carbon or in between second and third, right? Yes. Then next is the butane which is an alkyne, C4H6 is the formula. Here also there should be at least one carbon to carbon triple bond, right? It can be here or it can also be in between 2 and third carbon atom, second and third. So therefore I am drawing two skeletons for this, right? To satisfy the tetravalency, I can attach the hydrogens to them like this. Okay, so you can understand. For alkanes it is always fixed, because for alkanes there are only single bond present, but for alkenes and alkynes there are double and triple bonds. The positions of double and triple bond may vary, on the basis of that the structure will be different, right? On the basis of that the structure will be different. As structure will be different, properties, some properties also will be different, right? Okay, now this part of how to draw the structures and all for alkenes and alkynes with respect to the position of double and triple bond, we are going to discuss, but in the next class. So that's all for today. I hope it is clear to you about homologous series of alkane, alkenes and alkyne. Similar to alkane, alkene, alkynes, we can draw the homologous series for all other different organic compounds, maybe aliphatic, aromatic, or saturated, unsaturated, or alicyclic hydrocarbons as well. That's all for today. I hope it is clear to you. So we will end the class, but before ending, let me just show you the daily practice problem, how to upload the daily practice problem on the portal. So let me just share it to you. So I hope you are able to see it. So this is a teacher's portal. Similarly will be yours also. You have to go to resources, then to writing material. In writing material you will be able to see DPP, daily practice problem. You can just open it, you can download it, you will be able to see the questions here. You are going to write down the answers and solutions of the questions on a notebook or any blank paper. You are going to take a picture of that paper image, and you are going to upload it on your portal, just like you upload the image on any social media. Okay, and then teacher will receive it, and teacher will evaluate and tell you the suggestions and corrections. Okay, yes, fine. So let us end the session today. Let us discuss the next part from this chapter in tomorrow's session. Thank you so much and take care.